Hello, scholars. Today I'm going to go over some things that are familiar to you, but we're just building on that information. So let's go ahead and read. Lynn and Andre start walking toward each other at the same time from different ends of a 22-mile walking trail. Lynn walks at a speed of 2.5 miles per hour. Andre walks at a speed of 3 miles per hour. Here's a table showing the distances traveled, how far apart Lynn and Andre were over time. Use a table to find out how much time passes before they meet. So, whenever I see like something that's a little challenging or a little just like ambiguous and confusing, I like to like create a model. But before I could do that, let's write information that we know. We know that they are at opposite speed. They are at opposite ends because they're walking towards each other. Right? They're at opposite ends. I also know that their speed or miles per hour is different. So that means that their pace is different. Okay. Andre is going 3 miles per hour. That's his speed. And Lynn is going 2.5 miles per hour. Right? Since the constant is an hour, right? It's clear that Andre is going faster than Lynn because Andre is going more miles in the same time. However, that's not what this is asking, right? This is asking to figure out how far apart are they over time. So if we could just draw like an understanding of what that means. So Lynn is here, Andre is here, right? The total distance between the two is 22 miles. You see that? Andre is going at a speed of um Andre is going at a speed of 3 miles per hour. Lynn is going at a speed of 2.5 miles per hour. Also, it's good to note that if the distance is 22 miles, somebody is going to be at the 0 mile mark, somebody is going to be at the 22-mile mark, right? So in 1 hour, right, Lynn covered 2.5 miles, right? And that puts Lynn at 2.5 out of 22. You understand? So like if it started at 0 out of 22, now he's at 2.5 out of 22. It's a little bit further, right? Andre is going 3 miles per hour. So in an hour, Andre traveled here, right? So If Andre is at the 22-mile marking, Andre's time is being subtracted. Okay, from the 22. So 21, 20, 19. So Andre is at the 19 out of 22 miles per hour mark. Let's just go one more time so that we could get this. So another 2.5 miles, right? So that'd be at 5 out of 22. And then another 3 miles, right? Will be at 16 out of 22, right? At another 2.5 miles, will be at 7.5 out of 22. At another 3 miles, will be at 13 out of 22, right? At another 2.5 miles per hour, will be at 10 out of 22 mile mark. And at another 3, will be at also the 10 out of 22 mile mark. So it means that they'll meet up at 10 out of 10 miles out of the 22 miles, right? So that was a visual example of like what this means, right? They'll meet up together at the 10-mile mark in 1, 2, 3, 4 hours. So let's look at this. Let's look at this table. So go ahead and fill this table in. And let's try to understand what this table is what this table means to help us understand this in another way, right? So in 0 time, which is elapsed times, this table shows the time for all of it, the distance and the distance for both Lynn and Andre, and then the distance apart. That's what this is, right? So like in 1 hour, Lynn went 2.5 miles per hour and Andre went 3 miles per hour. 2.5 plus 3, right? So like, just so I can put something right here so you can understand what this is saying. That's 5.5, which means it's being subtracted from the 22 because that means that in total, right? This is like a part, whole situation. In total, they are 5.5 miles apart, right? Len went further, they went further. In total, that is 5.5 miles apart in 1 hour. They've traveled 5.5 miles apart. So that's from the 22. Thus 22 minus 5.5 is 16. So let's look in 2 hours, right? In 2 hours, to get from 1 to 2 is to multiply by 2. So we know that this is 5, which makes sense here. And we know that this is 6. Right? And the 2 represents the hours, right? That's the constant, right? So this is saying like in 2 hours, Lynn traveled 5 miles, which is here. In 2 hours, Andre traveled 6 miles, which is here. Total, that's 11. So 22 minus 11. That puts them at 11 miles apart. And what does that mean, right? So look, this is where I'm talking about. So this total distance and this total distance right here, this total distance and this total distance total 11 miles. So before they were 22 miles apart, then they became 16 miles apart. So they're coming together, right? They're coming together, right? Now they're 11 miles apart. Okay, let's see what happens in hour 3, right? So it's from 1 to 3 times 3, 7.5, and 9. So this is hour 3, right? 9. So that's 16.5. So that's 5, 11. So now they're 5.5 miles apart. Okay, because that's subtracted. So in total, look, I'll give an example. This plus this is 5.5. This plus this is 11. This plus this is 16.5. This is the total distance that they went, and you have to subtract that from the the distance. Well, this is the distance that they each went, and you have to subtract that from the total distance. So now they are 5.5 miles apart. This person is here. This person is here. You understand? Now let's look at hour 4. Okay, 10. Oh, so now both of them traveled 22 miles, which makes them 0 miles per heart, which means here they meet. So it looks like they met at the 4-hour mark, right? Go ahead and rewind this. You're gonna have to use this skill to help you um, solve the problems at the end, but this is just a beginner, and we'll keep talking about this, okay? All right, so here it says, what is the speed in meters per minute? Using the following information, assuming that there is a constant rate. So we know that speed is distance per time, right? And per is very specific. So like per time right here is asking for meters per minute, which means that how many meters in 1 minute, okay? So looking at this, I see some decimals. We know that we could, whatever per is, which is 1, we can find our distance. So like we know if we have unit rate of time, we know speed, right? So using this table, We automatically can determine speed because the unit rate is 1. And at 1 minute, they went 30 meters per minute. So the speed is 30 meters per minute. That was an easy one, right? But it may not be as easy to a person that don't really understand what speed is. Now, we can also check. We know that to get from this to this, we have to divide it by itself, right? And watch this. Basically, that's saying to figure out how much time in 1 minute, you have to divide 7.5 by 0.25. Because what you do when you divide something by itself, it becomes 1. And then what you do on one side, you have to do on the other. Right? So we're gonna figure this one out. And so we're saying 7.5 divided by 0.25. Look at that. It's 30, right? We can also look here. We know to get from one side to the other, when we're finding the unit rate of time, we just divide time by itself because that gives you 1. And 37.5 divided by 1.25. Let's see, if it gives us 30, then we know that that is correct. 37.5 divided by 1.25. Look at that, 30. So we know that the speed is 30 meters per minute. 30 meters per minute. Now let's look at this one. What is the missing speed using the given rate in the table? What is the missing distance? Huh. But we know that distance is speed per time. And in here, the speed is miles per hour. Okay. Uh, we know that to define the time and the time per means 1. So you're looking for 1 hour. And we know how to do that. We know to divide a number by itself in the hours will equate to 1. And then 300 divided by 5. So the speed is 60 miles per hour. Now, how do we find this? We know that if we multiply the time by the speed, we get the distance, right? Because 5 times 60 is 300, which means we have to multiply 0.10 times 60, which is 6. Okay, same thing here. It's times 30, right? And if you did not have this, you could just divide it by 30 to get to the other side, right? So speed is 60 miles per hour. The missing distance was 6 miles per 1/10 hours. Okay. The last thing we're going to review is this. Last Saturday, Mr. Ray drove to Delaware. When he drove 80 miles, he was 60% there. How far is Mr. Ray's trip? So what do we know? We know drove 80 miles. We also know that 80 miles is equivalent to 60%, which means he is not there yet, right? Right. He has like 40 more percent to go. Now, what we got to figure out if, right, here's, I like to write a sentence. If 80 miles represent 60%, then how many miles represent 100%, right? And so we go to our table, and I'm gonna solve it a few ways. Since we're dealing with 60%, I know if I have a tape diagram, I know I'm representing 20%, 40%, 60%, 80%, 100%, right? So I know I need 5 boxes, right? And using the information that I know for here, I know that this is 20, this is 40, this is percentages, and this is miles, 60, 80, 100. I also know that at 60%, I went 80 miles. I know. And so, like, you don't know what this is. You don't know what this is. But I do know one thing. I do know that I can go from 60 to 20 by dividing by 3 or multiplying by 1/3. And what I do on one side, I do on the other. And so to find 20%, I need to divide 80 by 3. So this is 26 and 2/3. Right? If that is 26 and 2/3, I know to get from 20 to 100. So I have to multiply 26 and 2/3 or 26.6 times 5. Put me at 133 miles. So, right, because everything is about 26 and 2/3 of a mile. Now, let's look at it using the table. Here's what we know. We know we're doing percentages and we know we're doing miles. We know that at 80 miles, it is 60%. What we don't know is 100%. I leave a space for friendly factor because I can't go from 60 to 80 with a whole number, right? So what I can do though is I can say 20 is a friendly factor, which is to divide by 3. And this is going to be 80 over 3. And then to get from 20 to 100, it's times 5. And basically, it's like 80 over 3 times 5, which is 40 over 3. 400 over 3. And 400 divided by 3 is, yeah, 133. Okay. So the answer is the total distance is 133.3 miles. Okay, let's do this. Colin can run 12 meters in 8 seconds. So what's the distance? Distance is meters per second, right? We know distance is time per, which is 1 per distance. We know that it's meters and time is seconds. And we know 12 meters in 8 seconds. We know we could just divide that by 12. Nope. The reason why we're not dividing by 12 is because we're trying to figure out per second. So we got to divide it by 8. Meters, 12 eighths meters per 1 second, right? Um, Let me just make sense of that one more time. So if we know that 12 meters in 8 seconds, you got to figure out 1 second. To do that, you have to multiply by 1/8 or divide by 8, whatever, right? And when you divide by 8, it becomes 12 eighths. But Colin can run, that is 12 eighths meters in 1 second. And you could divide it 12 eighths, which is about 1.5 meters per second. Okay. Now we're looking at seconds per meter. Now watch this. Watch how it's a little different. Before we knew it was 8 seconds and 12 meters. However, we're not trying to find per second anymore. We're trying to find per meter. So for 1 meter, right? And when I multiply this by 12, or I mean, divide by 12 or multiply by 112, that's pretty much giving me 1. But that means this has to be 8 over 12 because I have to divide it by 12. 8/12 seconds, which is about 2/3 of a second. You could put 8/12 seconds in 1 meter or 0.66 seconds in 1 meter. Now here it says how many seconds will it take you to run 30 meters? Do you know how many meters, you know how many seconds to go per meter? If you know that, you can figure this out. We know that is 8/12 seconds for 1 meter. If we're trying to figure out 30 meters, we just multiply that by 30, right? And then you have to multiply 8/12 times 30 over 1, which is 8 times 30, which is 240 over 12, which is 20. So which means it will take 20 seconds to run 30 meters. Sorry, I can review that again. So it says how many meters per second? That's saying like how many meters in 1 second. If we know there are 12 meters in 8 seconds, we could figure out how many meters in 1 second. We realize that it's 1.5 meters in 1 second because if you're finding 1 second, you divide 8 by itself. What you do on one side, you do on the other. So you have to divide 12 by 8, which is 12/8 meters in 1 second. Here is different, right? We know that there are 12 meters in 8 seconds, but we're trying to figure out per meter. And to get 1, you have to divide 12 by itself. 12 divided by 12 is 1. So you have to divide 8 by 12, which is about 2/3 or 66, 0.66 seconds, or 8/12 seconds in a meter. You can use the fraction. The fraction works. You'll still get credit. Now, the reason why I like the fraction is because it helps me understand that, like, because in order to determine how many seconds it will take him to run 30 meters, you need to use how many seconds per meter, right? You can't use meters per second because it's asking you how many seconds, and we already know that they're going 30 meters. If we know how many meters in 1 second, we could just multiply that 1 second by 30. And what we do on one side, we know it's 8/12 of a second in 1 meter. So if 8/12 of a second is in 1 meter, you have to multiply that by 30. 8/12 times 30, and every whole number is over 1, will give me 240 over 12, which is equivalent to 20 seconds. And my answer in context is it will take him 20 seconds to run 30 meters. Now it's your turn. You have to solve all of these problems. Don't worry, you can go back to the notes. The notes will really help you, okay? Which is why I have you take the notes first. Bye-bye.